Thank you, everyone, for joining me this afternoon. My name is Rishabh Poddar. I'm the co-founder and CTO of OPAQUE. Super nice to have you. I hope you all had a good lunch. In this talk, you've heard a lot about verifiable AI, confidential AI, the importance of verifiability for agents in particular. In this talk, I wanted to share with you how OPAQUE is bringing this capability to the market and give you a glimpse of the OPAQUE platform along that process, and share with you what our point of view is on this space and how we enable verifiable and confidential AI. So to start off, I think we all understand at an intuitive level, right, that the modern AI stack is bleeding data. We don't yet, as an industry, perhaps, have a well-defined taxonomy or framework to reason through all the ways in which the AI stack is bleeding data. And therefore, before we can provide solutions and before we can attempt to answer the question around what it means for an AI stack to be confidential and verifiable, what we did at OPAQUE was we undertook a body of work where we identified all the layers of the AI stack and mapped out the different ways in which data can bleed. As a part of that exercise, we identified 8 broad categories along with 46 different exposure vectors that together, it's not an exhaustive list. We will keep refining and iterating over it, but it starts to map out the complexity of the problem. These are all the different ways in which your AI stack can bleed information. And what I'm showing you here is a snapshot of some of those ways. If you want a look at the more detailed report, please reach out to me. More than happy to share it and discuss it with you. But when we look at the stack, we categorize the stack in 3 distinct layers. Right at the bottom, you have the compute plane, right? This is your infrastructure, your software infrastructure, your hardware infrastructure, your memory, your databases, everything that gets deployed to deploy your AI workflows in stack. On top of this compute plane, you have the control plane. This is where your business logic resides. This is where you define agents and agentic workflows and decide what an agent is allowed to do, how it reasons, what systems it can access, what tools it can use, what actions it can take. This is where your business logic is resident. And on top of that, you have the application layer. So this can be a chatbot or any other application that is getting powered by your agent system or your AI system. Each of these 3 layers can bleed data in a variety of ways. Some of those ways are the responsibility of the application developer. Others are the responsibility of the software vendor. Others are the responsibility of the infrastructure provider. So when we started looking at, okay, what can we tell our customers about, here is how OPAQUE helps you deploy confidential and verifiable AI. Where is it that we can make a difference? This was the reason why we tried to map this taxonomy out and identify all the different ways. And in particular, where we see ourselves as is in the compute and control layers. And you'll get a deeper understanding of this as I show you what the OPAQUE platform is and how it enables customers to deploy agents on their most sensitive data. But starting at the compute layer, we all understand data can leak in use, right? Nelly defined this very well in her keynote as protecting the mind. When your data is in memory, it can leak to operators, engineers, anyone who has access to those systems. Operationally, you are connecting your observability stack, your logging stack, which can also contain sensitive information if you don't take care of what your system is allowed to send to those systems. And there is a proof gap as well. How do you prove that any systems that you are deploying are in fact compliant with the organization's regulation or organization's policies or any federal regulations? Higher up at the control plane, how do you identify? What does agent identity even mean? Previously, you have humans with credentials. When we're talking about agents, what is an agent's identity? Is it the parameters of an agent? Is it the behavior of an agent? Is it some subset, some combination of this? Without answering the question around agent identity, how do you know which agents are allowed to use with systems, because the wrong agent, if you're allowed to connect to your system, can simply leak or exfiltrate data. When agents take actions, they're producing outputs, they're sending it to other systems. In doing so, they make leaked information as well. And there is a gap in terms of policies as well, because when you're enforcing a policy around an agent, that is not the same as demonstrating that or proving that the policy holds. Because with Mythos and others, using software to enforce software is dangerous. So the only secure pluggable way of enforcing protection is at the hardware layer. And even higher up at the application, where the organization that is deploying these workflows is building a variety of applications, there can be vulnerabilities at the app layer as well. Access control. I need to ensure that user A is authenticated and cannot get access to user B's data. Any results that are sent back to the user as they engage with the application, those results should only contain information that that user is allowed to see. So this is the plethora of ways. Our point of view is that we provide protection. So when we started just building out our platform and capabilities, the guarantees that we make are around the compute and control plane layers. And we give application developers the tools that they need to reason about leakages and vulnerabilities at the application layer as well. To do this, I've gone over the struggle around, what are the different ways in which agents can leak information? To solve this problem, we took a two-step approach. One is a software-based control. Right? So this is what we're calling opaque agent control. This is a software-based capability that allows you to control or specify what actions agents are allowed to take. What is it that an agent can do? It's deterministic. It assigns identities to agents based on an agent manifest, and it is pluggable with any framework. We have built this capability on the Agent Governance Toolkit, which is widely becoming the standard. It's new. It has 4,000 plus stars on GitHub, hundreds of thousands of downloads per month. And our agent control is built on top of the Agent Governance Toolkit framework that was released by Microsoft a few months ago. This is a software-based capability. This allows users and enterprises to start enforcing protections around agents as they are developing and iterating with their workflows. Once they are ready to deploy to production, this is where the OPAQUE Confidential Core comes in, where now these controls are deployed on top of the OPAQUE platform, which enforces those same policies and configurations and capabilities with the help of confidential computing, makes it attestable, makes it verifiable, and allows enterprises to bring their own existing workloads as well, in addition to any workflows that they are defining inside the OPAQUE platform. So agent control allows users and enterprises to build faster and develop faster, and OPAQUE's confidential core allows them to actually deploy this to production with the guarantees that they need. Architecturally, this is what the OPAQUE platform looks like. OPAQUE is deployed in the customer's environment, in their cloud, be it GCP, be it Azure, and soon AWS as well, or sovereign deployments. The platform, which is deployed in the customer's environment, so the data plane, which is where the actual computation happens, always remains in their control within their four boundaries. All that runs on OPAQUE side is a lightweight administrative plane, the admin plane, which is responsible for metadata management, configurations, and so forth. Customers and users can interact with the data plane in a variety of ways, using a command line tool, using SDKs, or using our web-based front end, which I will give you a glimpse of shortly. They deploy the data plane on a Kubernetes cluster that they manage. So it could be AKS, it could be GKE, it could be their own open source-based deployment. No matter what the Kubernetes offering is, we want to be deployable in any environment meet the customer where they are without them having to re-architect their systems, without them having to move their data or change the way in which they orchestrate these systems in any significant way. So as a result, the decisions we made were, okay, you already have a Kubernetes deployment that you're managing. You should be able to get the confidential guarantees that you need by being able to deploy OPAQUE on that same existing cluster without having to tear things down or spin new things up. Crucially, and additionally, they can connect their existing data sources and existing tools and services that they are using as part of their broader AI stack with the OPAQUE platform as well. For instance, if your data is in Snowflake or Postgres with governance in place, you should be able to use that data confidentially within OPAQUE when your agents are taking actions on it as part of different applications or workflows without having to move the data to OPAQUE or to a new confidential environment. Similarly, if your organization has policies around certain services that they already trust and are using, for example, a number of our customers are already using Azure OpenAI. Azure OpenAI has been vetted by the organization they trusted, or Gemini on Vertex, or Dataflow on Google. They should be able to continue using those tools until such time as, and this is where the future of confidential computing is, until such time as these services are also deployed confidentially, at which point we'll be able to mutually attest them to. So this allows our customers to plug OPAQUE into their existing environments without being disruptive, start deploying their most security critical assets and agents in OPAQUE, and then grow from there. One point I want to highlight is that even though the platform, when it connects to external data sources and external services, it's not mutually attested, right? Because the other side of the endpoint is not running inside confidential computing. Anthropic's models or OpenAI's models, they're not running inside confidential computing. So you can't really attest in the sense that you can't really get a proof that, yes, this is in fact the model that was actually built and deployed by the foundation model provider. What you can do, though, is attest the policy. Specify a configuration that, okay, these agents are only allowed to connect to these endpoints, only with these parameters, and that is enforced by the platform. So it only connects over TLS, the policy and configuration is attested, and therefore you are guaranteed that when the agent connects to the external system, it is doing within the confines of that particular configuration of policy. And the root of trust, of course, here remains the hardware vendors, Intel, AMD, NVIDIA, and so forth. As a result, when customers are deploying agents, before deploying anything at all, they can verify the system. They can verify the entire stack from the hardware to the software infrastructure, right up to the workload itself. So what OPAQUE adds on top of existing confidential computing infrastructure is the ability to attest the workload itself that gets deployed to, be it a simple agent, be it a graph, an agent pipeline that you have built. That gets bound to the identity of the workload. And before you connect any data to it, before you send any data to be processed by the workload that you're deploying inside OPAQUE, you verify the entire workload end to end, from the application down to the hardware. Any policies that you enforce on the workload are bound to its identity as well. And these policies, as a result, get enforced by the OPAQUE platform when the agent or your workloads are processing the data. And this enforcement is done at a hardware level with the help of confidential computing. And afterwards, you can export reports, dashboards, raw tokens, JSON, whatever you need, to demonstrate to your auditors, your regulators, that you had deployed the intended workload with the right policies in place. So anyone can independently verify, your internal auditors or your external auditors, that yes, the correct models, the pre-approved agents were used, and nothing else. So it's independently verifiable as a result. So let me now give you a glimpse of what this means in practice, right? What does the OPAQUE platform look like, and how do you use it? So what I'm showing you right now is our web UI. This is one way in which users can interact with the Opaque platform that they have deployed in their own cloud environment. They can use the command line as well. They can integrate applications to the environment, to the platform using SDKs as well. Um, what you're seeing here is workspaces. So workspaces are a governed domain within which users can create and deploy various kinds of workflows. Um, this workspace is called HR policies. Uh, and in this workspace, we have integrations, which allows the user to enforce governance around what models the workloads inside this workspace are allowed to use, what data sources are allowed to be used. When they're connecting to models, what parameters should they be permitted to use, what endpoints, and so forth. And as a result, this is a full catalog that any workload deployed in this workspace is guaranteed to adhere to. And if any workloads try to make use of resources that are not permitted by policy within a workspace, it will be prevented by design by the Opaque platform. Inside the workspace, you can create a variety of different workflows. Now, to create workflows, we provide an agent studio. This is a no-code canvas that non-tech savvy users can use to build and define agentic workflows. This looks like standard agent studios, but crucially abstracts all the complexities of confidential computing away from the user. So what this particular workflow does, it's a simple agent that connects to a chatbot in front for a use case where HR folks want to use a chatbot to answer employee questions. So this agent pulls data from a vector database, Azure AI Search. It pulls data from a SQL database, or it can pull data from an MCP endpoint as well. And it uses a policy-permitted Azure OpenAI model to take and inform its actions. This workflow is defined inside Opaque. When it's deployed, it's given a unique identity that is tied to this particular configuration and all the policies that were enforced at each node in this graph too. Now, in addition to using our canvas, users can also bring their existing AI workloads into Opaque without having to refactor or rewrite them by deploying them as containers. So that is the bring your own container capability that our platform provides, in which case the deployed container can be its own end-to-end workflow, or it can be a node that appears in this graph that they can then use to build richer and more complex capabilities as well. So if users have existing AI workloads defined, they can import them easily into this canvas and deploy them on Opaque too. The other thing that I want to show you is our trust dashboard. For all workloads and workflows deployed inside Opaque, you get a single trust dashboard where anyone can log in, verify that all the workloads have been attested with the right policies in place, and download the reports that they need for their internal or external audit use cases. So for example, for this particular workflow, this is a simple user-friendly attestation report that shows them, okay, this was the measurement of the workload that was securely deployed on actual confidential computing infrastructure with Microsoft's Azure Attestation Service as a root of trust, because in this case, it's deployed on Azure. They can download richer reports in the form of detailed PDFs, as well as raw tokens, which can then be used to independently verify by anyone as well. Because instead of relying on this particular report, you can actually download raw tokens with all the necessary cryptographic material and signatures in place that allows you to actually verify that, yes, this was indeed a legitimate attestation report and result. So hopefully that gives you an understanding of what it means to deploy and use Opaque in practice. What I will conclude with is, ultimately, these trust reports are about proving three things, right? Where was the workload deployed? On what infrastructure, what environment, with what platform configurations in place. What was the actual workload that ran? Um, with what configuration, with what policies, and all of that is tied to an identity that is given to the workload. And what rules held, what were applied and enforced when that workload was actually running. Um, and these manifest in a variety of ways. Runtime integrity policies. You want to make sure that only specific approved workflows are deployed and nothing else. Network policies. You want to make sure that no workload is allowed to communicate outside your existing network rules and configurations. Only approved endpoints can be touched and nothing else. And more detailed policies around who is actually allowed to access the systems when they are running. So you want to disable any access to Kubernetes pods and so forth. As a result, when you are deploying your AI workloads with OPAQUE, ultimately what you're getting is don't trust anything because you can verify everything before you're deploying it. And then after you have deployed, you can prove to anyone what was actually deployed and what ran. I will leave you with that, and hopefully that gives you a better look at OPAQUE's point of view on verifiable AI and how we bring it to customers. Happy to dive deeper into any and all aspects in case you all have questions. Thank you. Yes. Yes. Uh, Thank you, David, for the question. So the question I'll just repeat for the benefit of the room, and you can correct me if I misunderstood it, is how does long-term memory play into all of this? And I'm assuming the context being when you're deploying agents, agents can have short-term memory, they can have long-term memory, in order to build applications that are actually useful for end users. When we started, our starting point was to make everything stateless, in the sense that if you want to maintain state, let's do it on the application side of it first, before we start looking at long-term memory. But when you're deploying agents inside OPAQUE, from a short-term perspective, you get the encrypted memory at runtime through confidential computing, and the infrastructure is stateless so that there is no scope of information leaking across sessions between different users. The way we are looking at long-term memory right now, and this is not part of the platform yet, is by we would need to have support for encrypted vector stores, really, where encryption of the data is tied to key material or cryptographic material that is tied to individual users or groups or the enterprise's data, depending on how the data system is orchestrated. So that when a particular user tries to ask a question 3 days later that relies on some memory from before, the agent is only able to retrieve the relevant encrypted chunk from that encrypted vector store and then load it. This will also mean that the release of keys for that particular store is tied back to attestation and secure key release. So it's only released when the agent presents a valid user credential to the attestation service. It would, yes, exactly. Well, so architecturally, it would be policy independent, but the policy would apply at the verification layer, the attestation layer. Like the policy would determine release this key when the agent presents this particular identity. But I think the right answer there is we will need to include capabilities around encrypted vector stores or some kind of encrypted storage where the data is tied to individual users cryptographically. But thank you. Yeah. Thank you. So the question is, how do you extend attestation to the workload? Because that would mean that you are measuring the workload itself. Whereas with the remote attestation primitive that you get from confidential computing, it stops at the image that you're deploying in the. Um, so the way we do that is technically technically that's a policy. But ultimately, that policy does get tied to the attestation of the system. What I mean by that is our policy engine, our opaque attestation service, is part of the attestation stack. So when you're attesting that the correct software is deployed, you're attesting that this is the approved, vetted opaque attestation service that gets deployed as part of, or the approved opaque binaries, the approved opaque components that get deployed as part of deploying the opaque platform. Once you have attested the opaque components, the opaque attestation service, the opaque workload service, opaque identity service, opaque secrets manager, then you know you have a guarantee that those components will behave correctly in the future. So at runtime, when a user creates a workload, it is the opaque software that is registering those measurements and then proving to the user that, okay, this was actually what was deployed as well. This is for any workflows that are created using our UI, for example. In that case, the Opaque Studio and the Opaque Policy Engine will compute an identity for that particular workflow. Now, the other scenario is a user is bringing an existing workflow inside Opaque as a container. In that case, this is where the runtime integrity policy for the container comes in. The user registers the container with Opaque, and as part of that registration, they define this container that you're deploying must meet such and such requirements. It must have this hash, it must be signed, etc., etc. And then when Opaque launches that container, that is what it gets proven to the user later on. Because you have already attested the Opaque components that are going to then be responsible for launching the containers. So technically, attestation stops at the Opaque components boundary, and then the Opaque components are responsible for enforcing the integrity of everything that happens at the application level. If that gives you a mental model for how it's actually working under the hood. Yes. Um, Excellent question. So the question is, are there ways to suspend the rules that you enforce in the system to allow for debugging, testing, and so forth? Yes. So there are two ways, and both the ways apply to if you're using the UI in the studio or if you're bringing your containers in. If you're using the studio, we have something called the test mode. What that test mode allows you to do basically is actually see all the traces and the logs that get produced by each node as it's executing, put in prompts, see what the results are. Once you launch it and deploy it, then you don't have that visibility anymore. So that allows you to test and debug workflows that you're deploying using the studio. When you bring in your containers, you can specify a permissive policy. So containers can be deployed in 3 different ways. Permissive, standard, restricted, with varying degrees of controls. Permissive means I'm testing this right now, so don't have any protections on. Things are allowed to break. I'm allowed to see things. But if you but the attestation report will reflect that. When you're ready to launch in production, you switch to standard. So that is how we are thinking about enabling iteration. It's not perfect, but it's a measurable improvement. Um, yes, 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 yes. I mean, we used to run into this all the time. Like the first question we would get is, well, the whole promise of your platform is I can't see the data. But if I can't see the data, then how do I build things? And so this permissive policy in this test mode was in resolution of that core problem. Yes. So the question is, are policies user defined? And if so, can the data owner also specify policies as well? And show the proof to them. Excellent. So yes, policies are user defined. We also have a set of default policies that run in standard mode. For example, by default, no network accesses, no network egress is permitted, no shell access is permitted into the deployed pods. So everything that you need in place to ensure that the agent boundary is respected and that agents can't leak data inadvertently. So where the users can modify those policies is by whitelisting. Okay, my agent is allowed to use these tools, talk to these external systems. So that is the policies that OPAQUE enforces versus what additionally the users can define on top. Now, with regard to data owners, what data owners can do right now is, and this is how data owners are doing this in some of our production deployments, is by each workload that runs has an identity associated with it. Data owners can permission their systems, their data, their keys or secrets to only be accessed by attested identities. So if your data is, let's say, if your workload needs to use a key that resides in Google KMS, at the data source, at the key level, you can configure a policy that says, release this key only to this particular identity. And when the agent or the workload wants to access that data or that information, it needs to present a valid token that contains that particular identity. So data owners can control who is allowed to access their data with the help of the identity that each workload has when it gets deployed in the OPAQUE system. And before they permission it, they can get reports that prove that, yes, this identity is actually bound to that workload, which is in fact running inside confidential computing because it is part of the attestation evidence. So that's how data owners can configure policies around who is allowed to access their data. Finer-grained policies, it would depend on individual data connect at the individual data connector level, but then that would fall under the domain of the user of the system and not the data owner itself.